Hi there. Welcome to the module number 6 of the Food Chase training on smart and sustainable food production systems. Today, we'll be talking about optimizing harvest and storage to reduce spoilage. You will notice that during this module, we'll be talking about techniques on how to reduce spoilage. To avoid it is very difficult because we are dealing with a system that's not perfect, and we're dealing with the processes. And that's why everything we'll be talking about and everything we are looking at doing, you as a technician, is to reduce spoilage, because it's always happened, but we're looking at having mechanisms to take the action on the right time, on the real time, to decrease the potential problems. I am Professor Rafael, and I hope you enjoy this class. Let's start. The learning outcomes. At the end of this module, the students, you, will be able to explain how product physiology influences harvest timing and storage behavior, identify harvesting practices that minimize mechanical damage and quality loss, define optimal storage conditions based on temperature, humidity, and atmosphere, apply post-harvest handling strategies to reduce spoilage and extend shelf life, and align harvest and storage decisions with European Union food safety, quality, and sustainability frameworks. Okay? These learning outcomes will be backed up by the written material that has been shared with you, by the exercise for you to fix the module, which add from the reference, the technical references and the marketing reference I have shared with you on the written material. Let's start. The introduction to our submodule. Harvest and storage represents a critical transition between primary production and food supply chain. Okay? Primary there and food supply chain. Decisions made at harvest, back there on the farm, timing, method, and handling intensity directly influence respiration rate, moisture loss, microbial susceptibility, and mechanical integrity during storage and distribution. You see now, there is a holistic view. We must have a holistic view of potential problems to have a holistic result and holistic proposal of a solution, okay? Within the European Union context, spoilage prevention must be preventive and product specific. For each of products, you have one specific action or set of actions in line with the farm to fork strategy and cold chain regulations. Okay. The harvest and storage as integrated processes. We put together this title on purpose because when you think about integration of harvest back there on the farm and storage process as an integrate, you start to understand that we rely on each other. As this figure here has been extracted from a paper that's on the bottom of this page. When you access, there is a link. Just click that. It will lead you directly to the paper, to this study, and shows you and talks about how the farm influences on all the storage collection, distribute center, and end consumer. How it works, what the phases are, and how to understanding potential problems and act accordingly, okay? Some of the text to introduce you here. Post-harvest losses often arise from misalignment between product biology and storage conditions rather than from isolated failures, okay? Effective spoilage prevention requires understanding product physiology. Like one of the examples I have used before, a soft skin fruit is different than a nut. You must understand, okay, the product physiology. Not just the condition, but physiology. When does it get ripened? What's the amount what's the Brix amount of sugar I have in it? How should I speed up? How should I decrease the speed of it? You should understand physiology to act accordingly. Matching harvest maturity with storage objectives, very important. Coordinating cooling, humidity, atmosphere, and handling intensity, very important. You need some capacity to do that. You must be coordinate the cooling, humidity, atmosphere, and handling intensity. Very important, this point here. Harvest and storage must be treated as knowledge-based, integrated system, not separate operations. You see that? It's not just focusing on harvesting and then the other team will be focusing on storage. Even if you have two different teams, they must talk each other and you must have someone that will help them to understanding. So we have equalized rhythm, way of doing things, of different things and different actions. Harvest and storage is one very important relation thing. The other subject of this presentation, or the product characteristics determining harvest and storage. Very key. The objective, understanding how inherent product properties determine optimal harvest and storage requirements. The key characteristics, physiological activity and respiration rate. A banana has a different physiological activity and respiration rate than watermelon. Okay, they're very different. Moisture, an example, moisture content and water activity, same thing. Imagine a watermelon, the name itself explains how different it is from an apricot. Think about it. Sensitivity to ethylene and mechanical damage, very important. How it reacts with the ethylene, exposure and mechanical damage, okay? Physiological activity and respiration rate. You see the graphic here, which has on the X axle here, you have the respiration rate, and the Y, you have the storage life days. You see the difference between. This has been depicted from a paper that explain, the colors, what does it mean, and how they behave differently from each other. Okay, that's why I have said on a previous slide, fruits that have a different physiology, have a different growth rate, and etc. And this is reflected here. Harvest products will remain biologically active. Very important. Even when after harvesting, they're still biologically active. They have water, they have nutrients. Key principles, high respiration products, leafy greens, berries, deteriorate very rapidly. Soft skin ones, deteriorate very rapidly. Low respiration products, grains and pulses, store longer if stabilized. Okay? Respiration rates doubles with small temperature increases. You see that? Respiration rate doubles with a small temperature increases. Very important that to keep in mind. Immediate cooling and temperature control are essential to slow senescence and spoilage. Senescence is, if you're acquainted with the term, senescence, the end of the senescence is the spoilage. Okay, senescence is the act of getting ripe, is ripening, okay, and dying. Okay, imagine a leaf. It's green and later it's dark brown. This is the senescence, is the phase, is what's happening, senescence, losing carbohydrates, losing water, losing chlorophyll, and dying back, okay? It's very important to keep in mind. Moisture content and water activity. Wow, this is so important. Spoilage risk is governed by water activity rather than total moisture alone. High moisture products require high RH to prevent dehydration, okay? Excess humidity promotes microbial growth and condensation. Eye on that. Dry commodities must remain below critical moisture thresholds. This is very important when you control on storage. It's very different. If you choose to work with a product with a different moisture content and water activity, you must be able to have a different cool rooms, different rooms, storage rooms. Otherwise, you'll be homogenizing processes that are not welcome on this type of thing, okay? Effective spoilage prevention depends on balancing moisture preservation and microbial control. They are all totally related, okay? This has been taken from a paper. I advise you to read, but just gives a difference between moisture content and water activity. The moisture content, quantitative amount of free water and bound water in food system, measured using moisture meter, can be measured either in wet basis or dry basis, okay? On the other hand, water activity is a quantitative and qualitative amount of free water in food system, measured using water activity meter, okay? Not moisture meter, but water activity. And microbes use free water for their growth. This is the difference, okay? You see here the difference between those two. And very important to understand because water is something essential for growth, but something very sensible, something that keep your eye on that. Moistures are one of the main drivers of spoilage, okay? Ethylene sensitive and mechanical damage, you see? Ethylene accelerates ripening in senescence. You ripen and then you die. Key considerations. Climacteric fruits are highly ethylene sensitive. Example, banana. If you put apples with banana will be ripening very quick and senescent, become senescent very quick, okay? Cross exposure during storage increases losses. Example, we have two different fruits, one climacteric and another not. Crossing on the same cool room, you have a problem with that. You see the example of banana here. Mechanical damage increases respiration and ethylene sensitive. Very important, okay? Gentle handling and ethylene management are critical loss prevention controls, okay? Some of the impacts of ripening, when ripening is triggered by ethylene, short shelf life, okay? This is very important here. This has been depicted from a paper that's worth reading as well. Optimal harvest conditions are the chapter of this presentation, and the objective of this chapter is to show you that reduce spoilage risk by aligning harvest timing and methods with product physiology, how important it is, and focus areas on harvest timing and maturity indices, and harvesting methods and handling intensity. Let's explore some of those things. Harvest timing and maturity indices. Correct harvest timing ensures optimal physiological maturity. Okay, you have the optimal, remember. Good. Maximum storage potential. How long can you actually store it before it goes to the retailer, before it becomes spoiled? Reduced susceptibility to damage and decay. Very important of time. Okay. Key maturity indicators. Color development. You see on this figure here, you have a tomato here. Okay, you have the harvest maturity, look, the color, days taken to be red, look, the days, and treatments, okay, how cool, heat, control, not treated. Color development, totally, the color development is a very strong maturity indicator. Firmness and texture. Firmness is how hard it is. What's the texture? Soluble solid, bricks, and acidity. Soluble solids, like the amount of sugar you have in it, we call it bricks, and acidity. Physiological maturity markers. You can use some markers, to physiological markers, or maybe some chemical markers to understand if this is ready to harvest or not. Harvesting too early or too late significantly increases spoilage risk. Okay, this is another paper, shows the difference between the days taken to red from a fruit picked on different timing. Okay, read that. That's very important for you to understand how it reflects on spoilage. Okay, harvesting methods and handling intensity. Harvesting practices strongly influence poor harvest performance. Okay, loss preventive practices included can be seen as not just those four, but four that comes first to our mind. Minimizing drop heights and compression, unloading, minimizing drops, cushion it, or maybe decrease the compression, using sharp, clean harvesting tools. Okay, this begins on farm. Harvesting during cooler periods of the day. That's why if you check specifically apples, you see they always harvest on very early morning because they're soft skin. You gotta look after it. Rapid transfer to cooling facilities. Harvest, put on a main, cooling facility. Okay? Mechanical injuries at harvest often negate downstream storage investment. This is very important. You see on this figure here, this figure represents poor harvest and handling process of peaches. Peaches is very soft skin. You see the step 1 all the way to step 7. Harvesting, sorting, grading, cleaning, sorting again, packaging, and storing. You see how it does connect? It's very important. Everything begins on step 1. That's why we think holistically. If you work on a food industry specifically, and you're looking at having a better end product, it's very seminal, it's very important for you to understand how the harvest happened. Have a contact with your supplier. show interest. That will help them and they will help you, okay? Because you can actually identify, diagnose a potential problem that's happening there that's actually costing more for you to produce, okay? That's very important. That's why you think holistically for holistic problem, okay? Other thing, storage conditions based on product characteristics. This chapter has the main objective of design storage environments that slow deterioration while preserving quality. And the key parameters that we'll be talking about here are temperature, relative humidity, and atmospheric composition. Okay? Temperature, relative humidity management. Temperature, most influential factor controlling respiration and microbial growth. Remember, in one of the classes I have told you about that bacteria and fungus, they have an optimal temperature. That's why we understand the optimal temperature, we can actually influence by controlling respiration and microbial growth. Okay? Chilling sensitive versus cold tolerant commodities require different regimens. Okay? They must. Like I explained before, you need the different cooling room characteristics for soft skin fruits than for hard skin fruits. That's why we need to understand the chilling sensitive as cold tolerant commodities that require different regimens, okay? Regarding the relative humidity, the RH, high RH preserves turgor in fresh products. Very important, turgor, amount of water, richness, reflects on sensorial as well. Excess relative humidity causes condensations and decay. Low relative humidity is essential for dry commodities. Remember the nuts? Keep that. Temperature and humidity must be managed together, not separate. Here on the right-hand side, we have a figure from a paper, again, that talks about lower humidity and higher humidity, how we have these applied to different types of fruits, okay? How it reflects on energy consumption, reliability, and as well by different types of fruits and different types of conditions. Read the paper, that will help you a lot understanding how to act in the food industry that you're working depending on the type of fruit you're dealing with, okay? Regarding control the modified atmosphere, we call it MA, okay? MAP, and spoilage risk. Control atmosphere, actively regulate oxygen and carbon dioxide, used for long-term storage of fruits, perfect. Modified atmosphere, known as MAP, passive gas modification via packaging, suitable for transport and short-term storage, okay? Is a technique that's used, even though this figure here on the right-hand side shows the difference of using modified atmosphere and no modified atmosphere, okay? How we have the timing, how we have the deterioration percentage of this. You can read this paper and understand how modified atmosphere impacts on deterioration rates, okay? Storage-related spoilage risks include microbial decay. You must decrease the microbial decay. Chilling injury, perfect. Physiological disorders, hidden quality losses, okay? Continuous monitoring and sanitation are essential preventive measures. Again here, we have a word called continuous monitoring. Remember that? We don't do it separately. I'll do that in January. Now I am in October. No, you do that continuously because you're dealing with a very perishable thing, product. You gotta act accordingly. This was the module number 6. Has been a very technical again. You have seen that I shared with you some technical papers that you'll be able to access on the written material. Don't hesitate and click on the link, download and read. And the written material was aimed at actually making you stronger, technically stronger, and these presentations to actually just have an overview on it. They are complementary, okay? And the exercise actually will help you understand if you have absorbed the knowledge. It has been a pleasure teaching you this module number 6. I hope you have enjoyed this, and I see you on the module number 7. Wish you a great day, and thank you for your attention. I'm Professor Rafael Bonato. Thank you once more.